All right, so we can change the level and from 95% to other percents. Why not 100%? I mean, it'd be nice to always be correct. Well, the more confident we want to be, the larger the margin of error, the larger your net. So to be 100% confident, if you want to always make statements that are always correct, usually will involve making statements that are also pretty useless. For example, I am 100% confident that the average student is going to have a grade between 0 and 100% on the final. I've always been proved correct, and I'll be correct this quarter as well, but telling you the average is between a 0 and 100% is not particularly useful. I'm kind of reminded of this Garfield comic about the weatherman's making a prediction that the average temperature is between 40 below and 200 above. And the guy is never wrong. And that's sort of the issue of 100% confidence, is that you're never wrong, but you never say anything useful either. On the other hand, if we have a very tiny percent, say like a 1% confidence interval, we're going to have very precise intervals. However, you're almost never going to be correct. I mean, you're only going to be correct about 1% at a time. So, there is a tension between certainty and precision in confidence intervals. The more precise you want to be, the less certain the results. The more certain you want to be, the less precise the results. Fortunately, in most cases, we can be both sufficiently certain and sufficiently precise to make useful statements. And often, that's why we go with 95%. We're almost always correct, and we get reasonably good confidence intervals. But the choice of confidence level is somewhat arbitrary. So, I mean, there isn't any math that determines which level is best. It's basically your choice. The most common confidence levels are 90%, 95%, and 99%. And although any percentage can be used, you should be able to justify your choice. So in practice, using something like 92.9% or 97.2% is likely to make people think you're up to something. If you're not sure, just go with 95%. That's usually the default level. So suppose we want to consider confidence intervals where the confidence level is higher than 95%. Perhaps we like the confidence level of 99%. So if you think back to the analogy of the fish, if you want to be more certain that you catch the fish, you should try a wider net. In general, to find a confidence interval, we use this formula here, where we take the point estimate, and we add or subtract the z star, which is called the confidence coefficient, times the standard error. So z star corresponds to the confidence level selected, either 90%, 95%, 99%, or whatever. That z star times the standard error combined is what's called the margin of error. So, just to make your life easier, make sure you know these three numbers. So you should just have these memorized or have them written down somewhere where you can get them. These are the three numbers we'll be using a lot for the next week or so. If you want a confidence level of 1.64, a confidence level of 90%, we'll set the z star to 1.64. For 95%, we will use 1.96. For 99%, we'll use 2.58. So keep these numbers handy. So for instance, suppose I want to create a 99% confidence interval for the impact of the stint on the risk of stroke using the data we have here. So recall that the point estimate is 0.09 and the standard error is 0.028. Now for 99%, we would use 2.58. Okay. So let's go ahead and make a confidence interval. The point estimate is 0.09, standard error 0.028. The z star is 2.58. So I'll go 0.09 minus 2.58 times 0.028. I'll get 0.0178, so about 1.8%. If I add 0.09 plus 2.58 times the standard error 0.028, I get about 16%. So we are 99% confident that the patients receiving the stent were between 1.8% and 16.2% more likely to have a stroke. Now, if you're kind of following in terms of the conclusions, you might observe that sort of awkward language to describe a confidence interval. In general, the correct interpretation I want you to use is that we are such and such percent confident. So we are 90% confident, we are 95% confident, we are 99% confident, whatever the level is. We are such and such confident that the population parameter is between whatever values you get. So population parameter could be a proportion, could be a difference of proportions, it could be a mean, or it could be whatever. So for example, we are 99% confident the treatment group is 1.8% to 16.2% more likely to have a stroke than the control group.